Hi everyone. In P2, we built co-occurrence matrices, raw counts, and how often words appear together. But raw counts have a problem. Common words like the co-occur with everything, which isn't useful. So today in P3, we'll transform these raw counts using PMI, point-wise mutual information, to identify statistical significant word pairs. This is where we go for simple counting to meaningful relationships. So first, initially, let us know about what is PMI. So PMI measures how much more likely two words are appear together than by the chance. It has a simple formula which is PMI of W comma C equals to log of P of W comma C by P of W into P of C. If word co-occurs more than expected, PMI is positive. If less often, PMI is negative. For example, king and queen have high positive, so PMI because they appear together often. So king and banana have negative PMI because they rarely appear together. The tree transformation. P3 implements tree variants. The first regular PMI can be positive or negative, second PMI 0, shifting PMI where we subtracted log k using invert to vector implicit matrix factorization, and third is PPMI, which is positive PMI, where we have max of PMI comma 0, so keeping only positive associations. PPMI is the most commonly used because negative PMI values are often noisy and do not provide useful semantic information. Now here comes the question. How it handles zero count. So what about word pairs that never co-occur? Their count is 0. So PMI would be log of 0, which is equals to negative infinity. In sparse matrices, we simply don't store these entries. For PPMI, we explicitly include them since max of minus infinity comma 0 is equals to 0. This is efficient. Most word pairs never co-occur, so our matrix stays sparse. The output shows PPMI reduces density from 4.1% to 3.37% by filtering these negative values. The power of PPMI, that is the magic of PPMI, is that it downweights stop words. Look at the comparison of king by raw counts have counts like of, comma, the, just grammatical function words. But by PPMI, we see actual semantic content. So stop words have high raw content but low PMI because they are expected to appear everywhere. So PPMI sets these negative PMI values to 0, filtering them out automatically. Now let's see the output. So initially it loads the corpus and thereafter it builds the co-occurrence matrix and with matrix shape and non-zeros, and thereafter it gives the transformation matrices and sparse analysis, in which I have mentioned raw count matrix and PMI matrix, PMI 0 matrix and PPMI 0 matrix. So thereafter it also generated the visual distributions which we can go through. Thereafter, as I mentioned for Curie King, see, it shows like this, and the and city, and this is the complete distribution of the PMI. Now let's see the visualization. So this is the versus value versus frequency, and thereafter this is the linear scale and the log scale, and this is the raw count matrix, and this is the spectrum.png. So this is complete implementation. Thank you.